I'm just continuously amazed by how rugged we are. When I go jogging, for example, I'm counting on that seamless integration between my muscles firing, my nervous tissue just processing all the signals and sensations, like the skin on my feet being able to detect impact. It all has to come together. And we don't even think about it.
Unless you're Carmel Majidi, who thinks about it pretty much all the time. Because he makes robots. Not the rigid ones you might be thinking of, but rather robots that are more like us, flexible, strong, and capable of sensing their surroundings.
Soft robots in the future will be really necessary tool or machines in your daily life.
And these soft robots could be real game changers.
They could help us in our old age and assist with just even basic motor tasks, like just walking from room to room or going up the stairs. We can expect to see soft, biologically inspired robots that could be used in, say, natural disaster relief. They could kind of go through rubble and kind of squeeze through really tight-fitting spaces in ways that conventional robots or humans can't do. You could imagine using some type of soft robotic element to function as a kind of mechanical replacement for vital biological organs, say a heart valve.
Okay, so let's see one of these things in action. This is a robotic arm that Younglei Park and his students have built.
The main purpose is to help your daily activities.
Like eating or showering or retrieving objects. The overall design is a lot like your arm, a biological arm. It's got a rigid skeleton that's powered by a set of soft artificial muscles.
We use compressed air to contract these muscles, and these muscles are connected to different joints, so it creates different joint motions, like a human arm.
This is one approach to creating a soft robot. Another is to make it entirely out of soft materials.
This is a soft robotic finger. The finger is surrounded by artificial tendons.
The rigidity of the tendons, which are those black vertical stripes, is controlled by an electric current. Flip one switch to run the current through one set of tendons, and the robot finger, when pumped up with a bit of air, bends to the left. Flip the other switch, and the finger bends to the right.
We're looking at a soft switch. Unlike typical rigid components, its elastic properties allow it to kind of deform and contort.
Simply adjusting the voltage coursing through this flap causes it to bend. At first, something like this might be implanted into the human body, say, to act as an artificial muscle or heart valve. But once they're developed and refined, parts like this one and others that I'm about to show you could eventually be the building blocks of a completely soft robot. Now, these flexible materials are just the beginning. To make a robot, you also need circuitry to relay signals from the surrounding world. And for a soft robot, that circuitry has to be flexible too. So instead of rigid metal, the folks here use a type of metal that's liquid at room temperature, and it can detect if it's being stretched, touched, or pressed.
This is basically an effort towards making artificial skin for robotics. You could use this as, a wearable keypad.
Case in point.
I have a wearable arrow pad. When I put my finger on it, I'm completing an electrical circuit. So it sends a signal to the computer and allows me to play Tetris.
And here's another example, a sensor surface on the human body that responds to touch input. Today's soft robots are fairly small, and what they do is fairly limited. And yet,
you need to have imagination.
Before long, Younglei Park imagines engineering a flexible robotic skin to cover your entire body, kind of like a special wetsuit.
So you have a stretchable and elastic suit you wear. It's not going to be like a superhero suit, which generates a really high force and a lot of power, but the sensors embedded in your suit detect your body motions, and if you need to generate a little more force, that suit can generate your force.
Robots are machines that assist humans. Over the next few decades, we will have robots that are soft and a lot more like their biological counterparts.
The research teams at Carnegie Mellon are taking a variety of approaches to embrace this future. And if the robots get soft enough, they might just embrace us back.